we're going to break these down into five different ones here. These are the most common structural member used for typically for your columns and your beams. Structure. The reason I-beams are so useful and versatile is because of their shape, design. They can withstand or counter forces in multiple directions at a time. So a force at a specific point, she actually talked about in that video, is called a moment. Did anybody pick up on that? So the moment as to where the tower is pivoting from, the pivot point, the fulcrum, that is a moment. If there's a force being applied here, that is a moment. A moment is a specific location where a force is being applied on a structural member. Okay. So I-beams can withstand forces at multiple moments. You know, if I'll look at the shape of it, you know, you can apply force here, there, here, pretty much any way. And multiple places along these beams and columns. Okay. Now, angle iron is another very commonly used structural component. Remember, angle can withstand forces primarily in two directions. Y'all see that? This direction and this direction. Okay, now compare that to that I-beam. Y'all understand how many pieces of angle would it take to make that I-beam? Several. Okay, 4 maybe. So this does not counter as many forces as the I-beam does. Everybody see that? Channel iron counter more forces than angle iron or less? Look at how it's built, how many pieces it has. Okay, remember when we built the bridge, I said, you know, there's not much structural integrity in this direction with a flat piece of plastic or metal or false. But if you turn it in this direction, where it's extruded and the force is being applied here, there's a lot of structural integrity. Yes, channel would counter more forces than angle would because you have there, here, times 2, and here. Instead of just here and here. But would channel counter more or less forces than I-beam? Less. Channel iron would counter less. Channel iron would counter fewer forces than I-beam. Are y'all seeing that? Paying attention? Okay. This has less, fewer breaks and edges than this does. So this counters more forces in more directions than this. Key on that, I'm not saying weight. Okay. You can get I-beams, channel irons, angle irons, you know, whatever sizes you want to counter whatever weight or the amount of force that you're trying to counter. These different designs of structural members are just, you choose a design to counter more a higher number of forces in different directions. Okay. So now pipe has the same amount of material in 360 degrees around it. Right. So if you exert a force here, it'll be the same as exerting a force here, here, there. Pipe structurally could be a very useful component. Pipe is not used very often in structural design. I have seen pipe used in places structurally, primarily in like hoppers where something has to flow past it, because it also doesn't have much resistance. So if coal, for instance, has to flow over channel iron, some of it's going to get caught here and it'll eventually wear away the channel iron. But cold wood flow over pipe. But very seldom is pipe used in structural design. Does anybody have an idea why? Hold that thought, let's go to plate. What is plate primarily used for in structural design? Yes.
Shielding.
Shielding, yes. But is as used as shielding, it would not be figured into the structural integrity of the building. Let's go back to our components. Which one of these could you use plate? Right, joints. Okay, so if you're tying all these members together right here, you take a piece of plate with holes in it, rivet it, weld it, bolt it, whatever, to tie all those joints together. Call that a fish plate or a splice plate. Okay. Now, pipe is not. So all those, you can use plate because that surface is flat. All of those flat surfaces come together at that point. So you can use plate as a splice plate, right? You can weld a flat surface to a flat surface, right? I can't weld it, bolt it together, however you want to do it. Weld plate to the end of it. You bring it in and you weld plate to the end of it. And then you bolt it or attach it to a flat surface structure. Okay. That's not very economical. And so even though pipe would be very useful to counter structural forces, it's not very easy to build with. So ease of construction needs to be a key factor in your design also. So the more flat surfaces you have, the easier it is to connect in different configurations, right? To a certain extent. Welding angle iron to I-beam is very easy. Welding angle iron to channel is easy. You learn angle iron. I-beam to I-beam. There's so many surfaces that it gets a little tricky. Most of the time, if you're connecting I-beam to I-beam, you'll have a piece of plate right here in the web. Talk about the web of the beam versus the flange. Flanges are these flat surfaces. The outside, like the top and the bottom of the eye, the web is the inside. So typically there will be a plate welded inside the web, go and sticking out this way to go into another web of another eye. And it's just a common practice for welding I-beam to I-beam because there are so many surfaces. So these are your primary structural members.